Hello, calculus students. This is our last lesson on 1.1, and we're going to be covering the properties of limits, which they're beautiful, they're very straightforward, and some other special cases. So in your note sheet, you should see these properties of limits. This isn't something I'm going to talk you through. I want to encourage you to pause the video and look at the actual properties. Don't look at the examples. Read through each property and see if they make sense to you, because they are very straightforward. By now, you should have read through all of the properties. These are things you're going to need to know. You're not going to have like a sheet or a property sheet or anything like that. But again, they're pretty straightforward. So I'm going to just quickly go through each of these examples. So when I look at the example and I think of the constant rule and what it's saying, what it's essentially saying is I can pull any constant. I want to remind you that a constant is not a variable. It's a number. It's a defined number. So if I go up to the top here, I know that this limit was defined as -2. So I have 5 times -2, and I get -10. The sum rule is sum and difference. I mean, they follow the same suit. I'm simply breaking this up into two limits, and I understand that that is going to be -2 plus -8, and I'm going to get -10. Please try the example for the difference rule. I have a mistake here. I read, not wearing my glasses, and I read this limit wrong. This is 8, and this is 6. So there we go. Therefore, your difference rule, you will get -10. The product rule, essentially, all it's saying is you could take the limit of each function separately. And I'm writing this out in a very technical way just so you understand what's happening. And so we get 16. And I'd like you to try the last two examples, one for the quotient rule, one for the power rule. Okay, there you go. You can check your work. As we go on, we are going to end up with problems like this. Okay, and we're going to evaluate each of these using this information here. But one thing that we need to really talk about is, what is the limit of a constant? So if I say the limit is x approaches 2 of 8, let's first think about that. This is just a little side note. I know that the function equals 8, and that's the graph of a horizontal line at y equals 8. So no matter what x is, y is always approaching 8. So I want you just to keep that in your mind. The limit of a constant is a constant. It is the easiest limit, but a limit that students in the past have missed over and over and over. Please don't let that be you. So what I'd like you to do is, I'm not going to walk you through a lot of these, but I'm going to do these in parts. So I want you to definitely pause the video, work on A and B, and come back and let's check your work together. Okay, check it out. All right, we're going to move on to these next two. I'm going to work through C with you briefly, because again, it's one that's really not complicated, but in my past years when kids are assessed on it, a lot of my students will get it wrong. So I have the limit as x approaches 2 of 4 plus the limit as x approaches 2 of h of x. This is the limit that students tend to not know what to do with. And again, we have to know we're taking the limit of a function. This is a function of 4. So the output is always 4. So no matter what x approaches, y is approaching 4. If we go back at our rule at the top, we see that the limit as x approaches 2 of h of x is 2, and this limit is 6. All right. Try D. Pause the video, spend a moment, and D. So we're whipping right through these. They should be pretty basic. It might just take a little practice and just kind of paying attention to the small details. We've got 2 more. And once again, I'm going to ask you to pause the video and see what you can do and see if you can get these right by using your properties. Check my work, see how you feel. Again, these are the properties of limits. They're so straightforward, and know them. Know them quickly. So I want to refresh your memory back on day 1. I said, what can we conclude? And we looked at this situation and we had to make some decisions on it. So I want to go back and revisit that. And so I still have that graph from the other day in my calculator. And my question for you is, will it matter what number is in front of x on the limit? So if I want to make this 8, the only thing I need to make sure of is that denominator is 8x. Make sure you put that parenthesis around the denominator. And the limit still equals 1. And so what I can conclude from the other day is that if I have, and I'm going to write this over here as a side note, if I have a limit as x approaches 0 of sine of a of x over a of x, it's going to equal 1. And the thing that happens that students do wrong, they will get a right answer, but they do what I call illegal math. And when you take an AP test, most of your points come from your work. The final answer is like a point, and that's not a big deal. So the thing that students want to do is they want to mess around with this a. They want to factor it out in front of sine. And that couldn't be any more illegal, because a of x isn't what we call an argument. It's what's happening to the angle. If I pull it out in front, that's no longer true. We think about it in a transformation sense. What's in that parenthesis is affecting the domain. What's out in front is affecting the range. And so we can't mess with that. So please, please, please avoid it. This is a limit for now you need to memorize. Down the line, we'll give you a tool to help you do that algebraically. So the limit as x approaches 0 of sine of x over x is 1. But by the rule I came up with, as long as these guys match, these are also 1. Okay? And so we have to be very careful about that. So if I go ahead and I look at number 4, I can think about my rules of limits where that 5 can go out in front. And I'm really just thinking about this. And I'm not going to rewrite this like this all the time in the future, because it's just too time consuming. So I have 5 times 1, and that equals 5. Now I'm going to go ahead and I'm going to jump to 6, and I'm going to jump around a little bit, and then I'm going to have you complete some that I don't. 6 is a little tricky because it doesn't follow the rule. These don't match. And students just have that huge urge. They want to say, oh, well, that's fine. I could pull 4 out in front. And as soon as you do that, you've done illegal math, and it's all going to fall apart, and you're not going to get credit. So I have to treat this as an expression. And I mentioned this in a video prior. If this whole thing here, this entire thing is an expression, then I can only multiply it by a value of 1. I just have to be clever about it. I need a 4 in the denominator, but I need to multiply the entire expression by 1, so I must multiply the numerator by 4. So that has to equal 1. So this is what I truly have. Students tend not to like to show their work, but on a written portion of an AP test, that is just going to be vital. So now I can say that this is 4. I know you can get to this answer doing like wrong math, illegal math. I am telling you now, I promise you will lose all kinds of points, and your argument of, well, I got the right answer, not going to work for me. Okay. I am going to look at number 7. But before I do, I want you to pause the video and try to come up with a plan. So I want you to look at the statement I wrote in purple and say, and convince yourself that it is equivalent to what was given. That's what I'm thinking about in my head. I'm taking this 8, which is really 1/8, and just kind of putting it out in front. And now I'm going to create that 5 in the denominator, but since it's an expression, I can only multiply it by a value of 5. So what do I have left? I have 5/8 times 1, and I get 5/8. I'd like you to try number 5 and number 8. Number 5 and number 8. Pause the video. Okay? You can now see 5. 5 should have been pretty straightforward. We see that relationship going on there. Where 8 was a little trickier. So pause the video if you need to take some time and look over my work. All right, I also know in an earlier video I claimed that calculus is the gathering of all the math you've learned prior. It is so true, and here we go. I don't have a calculator. I have no idea what that graph looks like, right? And I don't have a rule. But I have a trig identity. I said it, trig identity. I know tangent x is equivalent to sine x over cosine x. I also know from basic mathematics, like algebra kind of stuff, if I divide by a fraction by something, I take the reciprocal. So the reciprocal of x is 1 over x. And then I know that I can rearrange this product because multiplication is commutative. And so I have got this beautiful thing going on. If I plug 0 in for cosine, cosine of 0 is 1, and this is 1. And I, as a teacher, would need to see all of this work. I don't want this video going too long, so on the back part of this note sheet, I'm going to go through a few problems, and then I'm going to save the other problems for either a virtual class or a live class, dependent on the situation. Since I have a monomial, one term in the denominator, I want to pull this guy apart, like prior to finding a common, like right before I combine the two terms together. I always, when I rewrite something, take a moment to pause and say, are they equivalent? And they are. So what I have is the limit as x approaches 0 of 1. Ooh, my handwriting. The limit as x approaches 0 of sine of 4 of x over over x. I'd like you to pause the video and see if you now can finish out the problem. I'm going to see if I have time to get this last one in. The rest, like I stated, we're gonna talk about in class. I went from like a sum to a product. So once again, I got to pull this apart. This is different than when I have that a sum and I have that common denominator. Products are a little bit easier to deal with than sums or differences with fractions, in my opinion, because I'm hoping that you are convinced that this is true. And now, check it out. I was writing an equal sign. And I'm done. Okay. I want you guys to really take this homework serious, work hard, because limits are a big deal in calculus, and we're going to continue using them. And I hope you have a great day.